The deep sea, a world of perpetual darkness and immense pressure, a realm shrouded in mystery, home to creatures of extraordinary resilience. Yet this unexplored frontier is now attracting attention, not for its biodiversity, but for the metallic treasures it holds. As terrestrial resources dwindle, the ocean floor, rich in valuable metals, beckons as a potential solution to our growing needs. But at what cost? The allure of deep-sea mining lies in the vast untapped reserves of metals like manganese, cobalt, and nickel, essential components of our modern world. Electric vehicles, smartphones, renewable energy technologies all rely on these precious elements. But as demand surges, so too do concerns about the environmental impact of extracting them from the seabed. Far below the sunlit surface, in the abyssal plains and seamounts, lie vast deposits of polymetallic nodules, cobalt-rich crusts, and massive sulfide deposits. These mineral formations, sculpted over millennia by geological processes, hold remarkable concentrations of metal. Polymetallic nodules, resembling black potatoes scattered across the ocean floor, contain manganese, nickel, copper, and cobalt. Cobalt-rich crusts encrusting seamounts are particularly sought after for their high cobalt content, crucial for battery technology. And massive sulfide deposits formed around hydrothermal vents hold copper, zinc, and gold. These metallic treasures, formed over eons, are now attracting the attention of mining companies seeking to meet the growing global demand for these resources. But accessing these riches comes with significant challenges. The deep sea is a harsh and unforgiving environment demanding advanced technology and substantial investment to operate. The thirst for metals is insatiable. Our hunger for technology, for progress, drives a relentless demand for the raw materials that fuel our modern world. Electric vehicles, with their promise of a greener future, ironically rely on metals sourced from environmentally sensitive areas. Smartphones, those ubiquitous companions, contain a cocktail of elements, many of which are becoming increasingly scarce on land. And renewable energy technologies, essential for combating climate change, depend on metals found in abundance on the seafloor. The deep sea, once considered a remote and pristine wilderness, is now caught in the crosshairs of this global resource race. The stakes are high. On one hand, the potential to secure the resources we need to power our future. On the other, the risk of irrevocably damaging a fragile and poorly understood ecosystem. Metals are the lifeblood of modern civilization. They are the building blocks of our infrastructure, the enablers of our technology, and the foundation of our economies. Iron for our bridges and buildings, copper for our wiring and electronics, lithium for our batteries and energy storage. These metals underpin our very existence. But as terrestrial reserves dwindle and demand continues to soar, the search for new sources intensifies. The deep sea, with its vast mineral wealth, offers a tantalizing solution. But this promise of abundance comes with a hefty price tag, the potential for irreversible environmental damage. The question we must ask ourselves is this: are we willing to sacrifice the health of our oceans for the sake of technological advancement? Can we not find a more sustainable path, one that balances our needs with the preservation of our planet? Section 5. Mining the deep technological marvel or ecological threat. Extracting metals from the deep sea is a monumental engineering feat. Giant machines, remotely operated from vessels on the surface, would crawl across the seabed, vacuuming up nodules, dredging crusts, or drilling into sulfide deposits. These operations would inevitably stir up sediment plumes, potentially suffocating marine life and disrupting delicate ecosystems. Noise and light pollution from mining activities could also have detrimental effects on marine organisms, many of which rely on sound and bioluminescence for communication and navigation. The potential for habitat destruction is a major concern. Mining could obliterate unique and slow-growing ecosystems, potentially driving species to extinction before we even have a chance to discover them. The deep sea is not a barren wasteland. It teems with life, much of it still unknown to science. The long-term consequences of disrupting this delicate web of life are difficult to predict, but the risks are undeniable. Section 6. Guardians of the Abyss, the role of the ISA. The International Seabed Authority, established under the United Nations Convention on the Law of the Sea, is tasked with regulating all mineral-related activities in the international seabed area, the vast expanse of ocean floor beyond national jurisdiction. The ISA is responsible for granting exploration licenses, developing environmental regulations, and ensuring the equitable sharing of benefits from deep-sea mining. However, the ISA faces criticism for its lack of transparency and its close ties to mining companies. Concerns have been raised about the potential for conflicts of interest and the adequacy of environmental safeguards.
The ISA is at a crossroads. It must decide whether to prioritize the exploitation of deep-sea resources or the protection of this fragile and poorly understood environment. The decisions it makes in the coming years will have far-reaching consequences for the future of our oceans.
Section 7. A delicate balance weighing economic gains and ecological risks. The potential economic benefits of deep-sea mining are undeniable. The metals extracted from the seabed could generate substantial revenues, create jobs, and boost economies, particularly for developing countries with limited terrestrial resources.
However, these gains must be weighed against the potential ecological costs. The deep sea plays a vital role in regulating the Earth's climate, absorbing carbon dioxide from the atmosphere and providing oxygen. Disrupting this delicate ecosystem could have far-reaching consequences for the entire planet.
The challenge lies in finding a balance between economic development and environmental protection. Can we harness the mineral wealth of the deep sea without destroying this vital ecosystem? Can we ensure that the benefits of deep-sea mining are shared equitably, both among nations and between current and future generations? Section 8. Voices from the deep, diverse perspectives on seabed mining. The debate over deep-sea mining is complex and multifaceted, with a wide range of stakeholders holding diverse perspectives.
Coastal communities, particularly those in developing countries, see deep-sea mining as a potential source of economic development and job creation.
Scientists are divided, with some advocating for a moratorium on deep-sea mining until more research is conducted on its potential impacts, while others believe that responsible mining practices can mitigate the risks.
Mining companies argue that deep-sea mining is essential for meeting the growing global demand for metals, and that they are committed to operating sustainably.
Environmental groups, however, are highly critical of deep-sea mining, arguing that it poses an unacceptable risk to the marine environment. Governments face the difficult task of balancing economic interests with environmental concerns. Section 9. The Uncharted Future. Navigating the uncertainties of deep-sea mining. The future of deep-sea mining hangs in the balance. The ISA is under pressure to finalize regulations for deep-sea mining, but many questions remain unanswered.
How can we effectively monitor and enforce environmental regulations in the vast and remote deep sea? What are the long-term ecological consequences of deep-sea mining? How can we ensure that the benefits of deep-sea mining are shared equitably?
These are just some of the challenges we face as we navigate the uncharted waters of deep-sea mining. The decisions we make today will have profound implications for the future of our oceans. We must proceed with caution, guided by science and a deep respect for the marine environment. The deep sea is a global commons belonging to all of humanity. We have a shared responsibility to manage this precious resource sustainably for the benefit of current and future generations. Section 10. A shared responsibility towards a sustainable future for our oceans. The deep sea is a vast and mysterious realm, teeming with life that is still largely unknown to science. It is also a treasure trove of valuable minerals, essential for our modern way of life. As we face the challenges of a growing global population and increasing demand for resources, the allure of deep-sea mining is undeniable. However, we must proceed with caution. The deep sea is a fragile and interconnected ecosystem, and the potential consequences of large-scale mining are still poorly understood. We must find a way to balance our need for resources with our responsibility to protect the ocean. This will require international cooperation, rigorous scientific research, and a commitment to sustainable practices. The future of our oceans, and indeed the future of our planet, depends on it.